So in this video, we're going to be working with rational functions. A rational function is a fraction where both numerator and denominator is a polynomial. Remember that a polynomial can be just a number, it can be just a variable, or it can be the multiplications and addition of variables and numbers. So for example, x minus 1 is a polynomial of degree 1. X plus 3 is another polynomial of degree 1. So in this case, we're going to just find this information. So we're finding the domain, vertical asymptotes, horizontal asymptotes, zeros, and y-intercept. Domain, as a review, is what values can I substitute for x for my independent variable, that most of the case we use x, that is going to make that this is defined. So a fraction is undefined only when my denominator is 0. So if my denominator is 0, my fraction is undefined. So to find the domain, it's the same step that we're going to do to find the vertical asymptote. I'm going to take my denominator and equal it to 0. So I'm going to take x plus 3 equals 0, and x equals 2, right? If I subtract 3 on both sides, I get that x equals to negative 3. So the domain, we're going to write it as x cannot equal to negative 3. Technically, we're supposed to write all real numbers except x equals to negative 3, but in this case, I'm just asking you to write whatever are the restriction. So if I substitute negative 3 here, it's going to make 0 the denominator. That's exactly the same value as my vertical asymptote. Right? The vertical asymptote is a line on the graph that the graph will never intersect, right? Because again, we cannot have a value where x equals to negative 3. My horizontal asymptote, this again is vertical asymptote, so it should go something like that on the graph, right? And then the horizontal asymptote is going to go like this. Now, my horizontal asymptote, keep in mind that it's describing what's happening on the end behavior. So what's happening in the stream left and what's happening on the stream right. It can intersect on the middle. So my vertical asymptote, I'm just going to look at my degrees. So on this case, my degree, again, this is 1 and 1, right? My degree, as a review, is the highest exponent of each polynomial. If the degree is the same, I'm taking the leading coefficients and dividing by each other. So this is going to be y equals 2, 1 divided by 1 is 1. If my degree of the denominator is higher than the degree of the numerator, then it's y equals to 0. And if the degree of the numerator is higher than the degree of the denominator, there's no horizontal asymptote. So next, my 0, right? A 0. I'm looking at where my fraction equals to 0. A fraction is only equal to 0 when the numerator equals to 0. Again, a fraction is only equal to 0 when the numerator is equal to 0. So to find the zeros, I'm going to take my numerator. So x minus 1 and equal it to 0. So that means that x equals to 1. So my 0 is x equals to 1. And we're going to write it also, because we are analyzing this on a graph, as a point. So my 0 is at x equals to 0. And as an x-intercept, it's going to be 1, 0. So last step, to find the y-intercept. To find the y-intercept, I'm actually finding f of 0. Right? Remember that on the x and y coordinate, the coordinate plane, right? I'm finding a number that intersects here, right? On this line, my x value is always 0. The same over here, right? On this one, my y value is equal to 0. On this one, my x value equals to 0. So to find where my graph is going to intersect the y-intercept, I'm going to substitute 0 for x. Now, keep in mind the following, because I have polynomials here. That means that my 0 is always going to be the division of just a constant term, the ones without variable, because I'm substituting a 0 here and a 0 here. So 0 minus 1 is negative 1. 0 plus 3 is 3. So I got negative 1 and 3. And I'm going to write it as f of 0 equals to negative 1/3. And again, it's an intercept. So that means that I'm going to write it as a point. Keep in mind a couple of things. Number one, domain. I'm going to write the x not equal to negative 3. The vertical asymptote, I got to write the x because it's a line, right? It's a line. So x equal to -3 is my vertical asymptote. Now the horizontal asymptotes, I can write as y equals to 1. Now the zeros, we're going to write it x equals to whatever is a zero. We can have multiple zeros of a function. So if I have a polynomial with a degree higher than 1, we can have more than one zero in a function. We cannot have more than one x-intercept because it's not a function. So x equals to 1, 1 and 0, and then f of 0 or y equals to -1/3, and then we write it as a point. Let's see this number 2 here. So again, let's start with the domain. Domain, I'm taking again my denominator. So x, 4x minus 2 equals 0. So 4x equals to 2 divided by 4. Get that x equals to 1/2. So that means that domain x cannot equal to 1/2. Vertical asymptotes where x equals to 1/2. Again, horizontal asymptote on this case is 1 and 1. So my degrees, I'm taking the leading coefficient. So now in that case, my leading coefficient is 2 and 4. So I get y equals to 2 over 4. That equals to 1/2. So my horizontal asymptote is y equals to 1/2. Now I'm going to take my numerator to find the zero. So 2x plus 1 equals 0. So minus 1. So 2x equals to -1. And then divided by 2, I get that x equals to -1/2. So x equals to -1/2. And again, we're going to write it as a point so we can identify also my intercept. My y-intercept, I'm finding f of 0. So that means that I get 2 times 0. 2 times 0 plus 1 divided by 4 times 0 minus 2. Again, this is 0, this is 0. So I got at the end -1 over 2. So my x-intercept is at y, or f of 0 equals to -1/2. So I have 0, -1/2. Okay, so my domain, again on this one, domain, I'm taking my denominator and equal it to 0 and solving for x. So x cannot equal to -1. That's also my vertical asymptote. My horizontal asymptote, again on this case, I get 1 and 1 as degrees. So I'm taking -3 divided by -1. That's y equals to 3. Right? My 0, I'm taking the numerator and equal it to 0. So -3x plus 2. And I'm solving for x equals to 2 over 3. So that's my 0. And then my intercept, I'm substituting 0 for x. So at the end, I should have -2. Let's see what's happening when I'm subtracting, right? So on this case, I'm subtracting or adding something to the fraction. Most of the things are still the same. My domain is going to be x equals to 0. Cannot equal to 0, right? Because I'm taking my denominator and equal it to 0. My vertical asymptotes, again, is x equals to 0. My horizontal asymptote now is a little bit different and a little bit easier because it's just that number. Whatever I'm subtracting, so my horizontal asymptote here is y equals to -2. Now, for my 0, I'm going to take 0 and equal it, substitute y for 0. So 0 equals to 3 over x minus 2. I'm going to add 2 on both sides. So that means that I got 2 equals to 3x. Then I can multiply times x on both sides. So this cancels out. So I got 2x equals to 3. And then I can divide by 2. So that makes that x equals to 3/2. So x equals to 3/2. And the point here is 3/2 and 0. Now, for the y-intercept, I'm substituting, right? We already saw it that I'm substituting 0 for x. But up here, we said that x cannot equal to 0. So that means that in this case, there's none y-intercept. Okay, so number 5, again, I'm taking my denominator, x minus 1 equal to 0. So x cannot equal to 1. My vertical asymptote, x equals to 1. Horizontal asymptote is y equals to 5. Then my zeros is x equals to 4 over 5. So again, for the 0, I'm taking my function and equal it to 0. Then I'm going to subtract 5 on both sides. Then I'm going to multiply on both sides times x minus 1. I'm going to distribute here the negative 5. So I got negative 5x plus 5 equals to 1. Then I'm going to subtract the negative 5. Then I'm going to divide by negative 5. So I got x equals to 4 over 5. And that's my 0. On this case, that my denominator is x minus 1. I can substitute then f of 0. So I got 1 over 0 minus 1. 0 minus 1 is negative 1. So 1 divided by negative 1 is negative 1. Negative 1 plus 5 is 4. So my y-intercept is 0, 4. And that's it for this lesson. May the force be with you.